thank you all for joining. This is the week ahead kickoff for the NANOG 87 Hackathon. We will be doing a quick virtual intro, give some time for people to who have ideas or things they would like to present to create team pitches, and drop some ground rules and then organize for next weekend. So for those of you who are new, thank you for joining. For those of you who are rejoining, hopefully this won't be too much of a rehash. So the hackathon, just to give you a bit of history, the hackathon was originally an idea that was brought to NANOG, I think 6 years ago at this point. One of our sponsor partners came to us with the idea and just asked, hey, is there any way we can get a room for Sunday? And we said, sure. And it turned out, and people had a great experience, and that particular sponsor worked with us for the next few ones, and then handed the reins to the NANOG program committee, which we took and ran with, and we've been organizing these ever since, bringing in partners, individuals, really anyone that wants to learn, anyone wants to help support. Over the past year or two, I think now, we've started more focus on working with open source projects. So you'll see a few people here that represent some of those projects. So just a quick overview. The NANOG Hackathon, Hackathon 87 is taking place in Atlanta, which is in Eastern Standard Time. So all times that you see here are going to be EST based. So if you're remote, just be aware of that. We will have virtual support hours from 1 p.m. to 4 p.m. on Saturday, from 12 p.m. to 4:30 p.m. on Sunday. So during those times, there will be people on the Zoom if you're remote, or if you're in the room and you have a question that you want to bring to someone who is not in the room, or someone that's virtual that can support you. Any questions, concerns, ideas, feel free to ask questions. At 4:30 on Sunday, we will officially stop the hackathon, and teams that want to present their projects will be given the time to do so. So if you think you've done something you want other people to see, that's your forum, and we'd be really interested to see what the participants come up with. Lots of good ideas always come out of those, even if what you've got is super rough, and you might have just an idea, maybe you don't have working code. That's fine. You'd be surprised how often an idea that gets presented catches someone's ear, and a collaboration result of that. We've seen that happen a few times already, and it's really quite interesting to see it happen in real time, and to know that we're part of an event that fosters that. So on Sunday, we'll have mentors in the room as well as virtual. I think most of the mentors will be in the room. But if you're virtual, just ping us either on the Zoom. We'll have a screen up on the Zoom or on the Slack channel. The room itself is 706 and 707 in the atrium level. It's going to be open 7 to 8 p.m. on Saturday, which is where we're going to have a quick tutorial on some of the projects that people have been working on. And then from 8:30 a.m. to 5 p.m. on Sunday, that room will be available, with tables and internet access and all the things that you would need to get a team together. The primary communication mechanism we're going to be using is the Slack channel. Everybody should have gotten an invite to the Slack and should be a member of the NANOG 87 Hackathon channel. If not, please reach out to us. if you're on a team, you can create a Slack channel for your team. If you need help, use the @mentors tag, and that will alert the team the hackathon mentors. Please do not use @here or @channel. @channel is fine in your own team channel, but not in the public channel, because that's going to ping everybody, and that's usually not going to get the attention you want. Just quick thing, make sure if you're going to be on Zoom, make sure you update your Zoom client. Occasionally they add features that not everybody has, so it's best to make sure everybody's on the same page here. Every hackathon we try to pick a broad theme and then go from there. We picked sources of truth this time, and we've got a couple good projects that people are going to be bringing to the hackathon in that vein. NetBox being one. Leo represents PeeringDB. Leo's been kind of a mainstay, but I think we're putting the ball in his court for this one. So I think both those projects will benefit from some attention this hackathon and some creativity that you all can bring here. We, as always, we have a lab infrastructure that's available. So if your team wants an instance of this lab, just let us know. We'll provision one for you. If you've done hackathons in the past, this will look very familiar to you. It's a container lab based environment, a small network to Arista virtual devices to Juniper virtual devices, and a couple hosts hanging on the end for any sort of in-band tooling or connectivity testing or anything along those lines. If you've already got a team, if you've already worked this angle, great. We'd love to get a roster of what your team is and who the members are on the team. If not, we can help you find a team to join. We'll be doing team pitches, so if those pitches seem interesting to you, contact those people and join their teams. If you're looking for something to do, we can help you find some people that you can work with to be creative and productive. All levels are welcome here. You do not need to be an experienced coder. We're all here to help and learn. And we get advanced developers, and we get people that are new to programming, and that works out really well because everybody learns and comes out from this knowing more than they did walking in, myself included, on a regular basis. And so that's really what we're all here for, is to learn, grow, and to better ourselves as engineers. As I said before, at 4:30 p.m., each group will be invited to present their work. We will coordinate that on Sunday. So if you have a team, if you have a project you want to present at 4:30 in that time slot, please let us know, and we'll make sure everything is set up for that. During the hackathon, some NANOG staff will be walking around doing interviews. If you're willing to be on camera and have some things to say, and want to answer questions, feel free. We will take that footage and use that for the recap that will be presented during the main session. I see Jeremy from NetBox, and I see Leo from PeeringDB is here. Let's start with Jeremy.
So hi, everyone. My name is Jeremy Stretch. I'm the founder and lead maintainer of the NetBox open source project. I'm just going to take a couple minutes on this call real quick to give a real quick introduction and suggest hopefully some projects that sound kind of cool that might be interested in doing for the hackathon. So if you're not familiar with NetBox, it is an authoritative source of truth for your network. I saw that this NANOG theme for the hackathon was going to be interacting with sources of truth, and kind of had to jump on this pretty much. But yeah, so NetBox is designed to model the desired state of your infrastructure. So that differs from the operational state, which is reported to you through various monitoring tools typically. It's essentially a way to document your network and its intended state and make that programmatically accessible. So this replaces and improves upon other, like legacy IPAM/DSIM tools that you may have used in the past, and of course, spreadsheets, everyone's favorite IPAM tool. It was released back in 2016, back when I was working at DigitalOcean. It is licensed under Apache 2. The application itself is a web application and includes both REST and GraphQL APIs, as well as you'd expect, a Python API, as the entire application is built on the Django Python framework. Very customizable, and it is extensible via plugins, which I'll talk about on the next slide a little bit. And we've got a huge, active, very, very active and growing community with no end of discussion. Here's a real quick, just kind of screenshot of what NetBox looks like. It might look familiar to you. Maybe you've seen it in passing. But as you can kind of tell from the left-hand side there, it's really built to kind of manage and track everything you might need to care about as a network operator. So what might you do with NetBox for the hackathon? Thought about this for a little bit, came up with some ideas. As I mentioned, NetBox itself is highly extensible and customizable. And as Chris mentioned, we obviously have a wide spectrum of skill sets here, but I'm confident that there's something you can find at any skill set. Even if you're just starting out with Python, and maybe you just want to get used to like programmatically interacting with the API or just different objects within NetBox, that's perfectly doable. All the way up to if you want to do your create your own custom plugin, or even work on NetBox core itself. That's also possible. So the first idea up here is the PyNetBox API client. That's out there. It exists as a Python client specifically for NetBox that makes it very easy to manipulate objects within NetBox using the REST API, but consuming it directly within Python. So instead of making raw HTTP requests, you're manipulating Python objects. Moving down, custom scripts are something that NetBox supports as well. So this is the ability to write a Python script that you can load directly into NetBox and then essentially render a form in the NetBox UI that'll allow you to automate tedious tasks. For example, maybe when you go to deploy a branch site, that you need three of this type of switch, and you need a router and a firewall, and you're going to use an IP prefix of a certain size. What you can do is actually script all of that out directly in NetBox, dump it into a custom script, and that becomes a form that you fill out in the UI. And then just by providing the information that you need to build out a site, NetBox will go and populate all the data for you according to the logic in your script. Another option would be a Slack bot. Those are pretty accessible and probably fit the time constraints of the hackathon pretty well. Just integrating the NetBox API through Slack, or I probably should have said Slack bot, but a chat bot, some other platform as well, just as good. Back up at the top right, as I mentioned, plugins are a thing. If you Google just NetBox plugins, you'll find some examples that are out there right now. And that's the ability to extend NetBox's own core data model and views to accommodate your own extensions to the data model. There's some very popular ones out there now that do things like BGP tracking. I think there's one for like dial plans and so forth. DNS is another one. So that's also something to look into. Might be a bit more of an involved project, but depending on your appetite, could certainly be something fun to take on. And of course, NetBox is an open source project. We're out there on GitHub. We have no end of open bug reports and feature requests. If you'd like to take on one of those, just look for anything that's labeled as needs owner. That's up for grabs. If you're curious about any of them, ping me directly. Happy to provide any context I can about the perceived feasibility or difficulty of anything that's on there. And finally, just something else to mention. We do have a device type library. Open source device type library, which is essentially static definition, like YAML definitions of all these different device types that are out there. So like Cisco, Juniper switches, everything pretty much that that you'll encounter in the industry. Pretty much someone has taken the time to document now. Whether there's anything to do with those or not, I'm not sure, but there's a lot of data there that could be kind of interesting to play with, even if not for NetBox, maybe for some other purpose. So they're basically just canonical definitions of devices and like all the interfaces and power ports and console ports and stuff like that you would find on a device. It's kind of like a dictionary, more or less, that defines all these different devices. So that's something else to play with, and I'll be providing a link to that and to all the other resources that I've mentioned here. I'll dump something in the Slack channel after this is done. real quick, here's a couple of resources that we have available. There is a public demo. If you've not messed with NetBox at all before, just want to go check it out, head on over to demo.netbox.dev. Log in as admin, and you can play around with that. That gets rebuilt nightly, so feel free to go crazy with it. Our documentation is available. Of course, GitHub is there as well. And if you get interested in playing with NetBox, of course, we have our own Slack channel over on netdev.chat. Just open up the NetBox channel, and you'll find a lot of people that are willing to help. Okay, that's it for me.
Let's see. I see Leo is here. Leo, do you have anything to present at this time?
I'm representing PeeringDB. We're bringing a project to the hackathon, and the idea is essentially that we'd like to help you take your internal source of truth, compare it against what you are sharing with the community on PeeringDB, work out what the difference is, and discuss how we could automate updating. So for people who don't know about PeeringDB, I've got one very quick slide here. You could think of PeeringDB as a kind of specialized Yellow Pages. PeeringDB describes networks, internet exchange points, facilities where networks and internet exchange points can place equipment. And as of last month, we have a new carrier object, which is intended to describe high capacity layer 1 and layer 2 connections into facilities. As you can see in the picture, the screenshot, when you have a connection to an internet exchange point, there's information about the speed of the connection and IP addresses associated with the connection. And this is essentially the focus area for the problem to solve. So many networks will have some kind of internal configuration source of truth. There are multiple different systems that people use, and sometimes they will change the speed of a port, or they will add a second connection. There's another IP address, and PeeringDB doesn't automatically get updated, but we know, based on the last 3 years of user surveys, that the quality of network configuration data shared in PeeringDB is one of the highest priorities for our users. Obviously, both for people who are sharing it and people who consume that data. So the goal here is to essentially help everyone in the community share higher quality data so that everyone wins. So we'd like, at the end of this, to have some people work out how they could perform a delta of what's in PeeringDB, what's internal, and work out what to change. Then we can work out how we could go and handle those changes. So obviously, one way to do that would be our API. You can send updates to PeeringDB through our API. The way you want to do that, we might want to have a conversation. Do you want to do it all in one go? Do you want to do them one by one? And some people will want to do this through the web and go and see some kind of red line difference, so they can go and do a comparison. And we might want to have a conversation about how that should work as well. So as much as we're looking for people to go and work this out in a programmatic way, we also want to have the conversation about, once we get to the point where tools have this functionality, how do we want to take advantage of it to actually deploy those improvements in the data? So these are the things to discuss. We've thought a little bit about what a high-level flow could look like. Fetch all of the internet exchanges that a network has a connection to, or maybe all of the internet exchanges, build a data model, calculate the difference, and then work out how we're going to do the changes. Benefits, of course, this could be of benefit to every network or internet exchange point or whatever that publishes data in PeeringDB, both in making themselves more amenable to interconnection, and it helps the community overall. This is also an opportunity just to learn a little bit about PeeringDB. We are a window into the NANOG community, and so if you have a network with a configuration and you'd like to spend some time on this project, you'd be very welcome. Now, some other people might go and say, don't like that idea. We've got some good first issues and a guide to getting started with developing PeeringDB if you just want to go and do some development work, and be very happy to chat with people about anything they're interested in doing for PeeringDB. We've had quite a few volunteer contributors over the last year or so. We've been getting better at supporting volunteer code developers. And that's it from me. Thank you very much.
Thank you very much, Leo. I can definitely see some value to that. And if you're interested, please reach out. Leo, I'm assuming you're going to be setting up a Slack channel. And so, post that in the main one. And if you're interested, join and coordinate and start hacking. Is there anybody else who would like to present an idea here while we're all here in one place?
I can go.
Okay.
I don't have slides though.
Oh, hi, Alex.
Hello.
An
idea. Yeah, so I was thinking, since you guys brought up this source of truth integration, I had that idea for some time, and essentially what I would like to see if it's viable and interesting for an actual use in the field and for lobbying purposes. Create a way to export NetBox data about the network topology portion of that, of course, into a format that can be easily deployed as a container lab environment or KNE environment, those modern container-based network topology emulation tools that we so love to use recently. So that's something I'd like to explore and see if I can find somebody who would like to participate as well.
Yeah, Alex, if you want to go ahead and create a channel for your project in the Slack and post the link to it.
Yep, sounds good. I'll do that.
Okay. Right. And if anybody is interested, feel free to join that and reach out. Whether or not you want to make use of the lab, I like to spend a little bit of time talking about it, just so people don't come in completely blind. As always, we're going to be here to help you with any issues you might have. If you want to walk through it or figure out ways to use it, or if you want to make changes to the lab. It's a fairly flexible topology model. So if you've got something you want to test out that requires something to look a little different in the lab, we've had a lot of the evolution of this lab has actually come from hackathon participants in the past. So, really love to see that progress in the future. We use Container Lab as our lab infrastructure management system. Container Lab, if you're not aware, is an open source project originally developed and published by our friends at Nokia. And it is primarily a way to define a network topology made up of Docker containers, each of which can contain a routing instance, and then can interact each other as if you're running on a real network. And the real advantage of that, in the past we've used labs consisting of virtual machines, things like VMX and Arista VEOS, and et cetera, is that because these are containers, we can provision them on demand in AWS without needing to worry about nested virtualization, which is always has its fun quirks and performance issues. So shout out to Michael Costello, a longtime actually now a NetBox board member who originally pointed us at this project. So really seen some good efforts and made a lot of progress for making this system easier for people to use. So it's a fairly simple topology. 2 Arista containers, 2 Junos containers, 1 CentOS, 1 Ubuntu instance hanging off of each end for connectivity testing and any tooling that you want to put in those containers that needs to run in band. Every device has a management port available from the base OS. If you've done hackathons in the past, this will look very familiar to you. The one change we made for this hackathon is that we have installed a NetBox server on the image. So if we provision you an instance, it will have a copy of NetBox running and with sample data pre-populated. If you want to start with an instance that has no sample data, that's something we can help you with also. There's some fairly simple instructions to clearing out that database. We will pin more detailed notes on the hackathon, including the SSH key to access it into the Slack channel. As I said, there's going to be a key posted, private key. It's the same private key for each instance. We're all friends here, and this is a lab environment, so just be nice to each other. Once you have an image provisioned for you, there's several ways that you can access the instances that are inside the EC2 image. The most straightforward one that requires a little bit of setup is to create SSH tunnels. Each instance has its own management address, and you can create an SSH tunnel to the instance's public IP, which then forwards to a given instance management IP, virtual IP inside the Docker network. You can do your development locally, push it to Git, and then pull it in the instance, or you can just SCP it to the host as well. Both of those mechanisms are fine. Or you can do your development work directly on the remote server if you choose. I've seen people do that with SSH-based SSH file systems. So you see the file system on the instance as if it was on your own desktop. So I've seen that work as well. This slide contains the topology and the addressing info. This slide deck should be shared, so you should have access to this. If not, I have a copy of the Graphel file, excuse me. If you want to look at it and try to make some changes to this, feel free to discuss, and we can walk you through the Container Lab topology file format. It's fairly simple and straightforward and pretty easy to manipulate. If that's something that interests you, please reach out and we'll help you with that. So, quick how-to on this. Download the key from the Slack channel and copy it into your .ssh directory on Mac OS Linux. I know a couple people have posted how-tos on how to do this in Windows. If you're a Windows user and know the step-by-step here, please share. I personally do not. Important thing is to remember that you must always change the ownership of the file to mode 600. SSH client, the SSH client will not read the private key if it is world readable or even group readable. So just make sure that you do that, and then you use the Unix SSH. Use the -I switch to point the client to that key, so you can use that for your authentication. Here's a screen capture of that process. When I do it myself, I export the keys file name as an environment variable for easier use in future commands. So pretty straightforward. And as always, reach out if you have questions or issues. Once you are in the lab, one thing to be aware of is that the CLab commands all require sudo because Docker runs as root in this environment. One command one command that's going to be useful is the inspect command that you see here. And there's a whole host of other commands that we can show you. If anyone's interested in a live demo, I can I can organize that. But generally, just make sure that all of your containers are running. And I see here that the CentOS container exited, so that's something to poke at and try to figure out why that's happening. And you'll see the management addresses for all of these, which are actually static in the topology file. So if you look those up, we can point you to where that file lives. Everything's going to be in the ops CLab directory. So poke around there, and there should be plenty of things to find to help you reason with us. Just a quick word about the OS instances. Because they're containers, the container access syntax requires an executable to be invoked. If you're familiar with the Docker exec command, you give it the container you want to access and the command you want to run on that. For any Unix-based instance, that's just going to be bash, but you do have to make sure that you invoke it. CEOS and CRPD have their own exec environments, and you have to invoke their command names, which are pretty simple, but with one important difference. CEOS is CLI with the C capitalized. CRPD, Juniper's container, uses CLI all lowercase. So just be aware of that difference. And if you're curious to see what that looks like, here's that Docker exec command being invoked to access one of the COS instances. And once you're there, you see pretty much the same thing you'd be seeing if you logged into a hardware-based, a real Arista switch. All the same commands should work as you expect them to. For CEOS, CRPD is a different story, and I'll talk about that for a sec. Quick word about COS. Very, very similar to iOS. If anyone knows the history, there was some intellectual property disputes over EOS's similarity to Cisco iOS. Most of your commands are going to be identical. The exceptions are, there are some exceptions, but they tend to be more when you go into more advanced configuration options. Almost all of your basic interface provisioning, router configuration, routing protocol configuration, et cetera, tends to be exactly as you expected if you're familiar with iOS. One important difference is that there is the configure session command, which is different from iOS's configure in that it creates a commit session that, much like Junos configuration mode, if you're familiar with that, you put in your configuration commands and then use the commit keyword to invoke those configuration changes in one shot. A very good idea that was taken from Junos that I'm very grateful for when I'm playing with my Arista boxes. Link to Arista's configuration language is in the slide deck. Should be easy to find in Google as well. So, but as always, many of us here are familiar with Arista and Juniper, so feel free to reach out if you need help. CRPD is a little bit different. It is a container that's running only the CRPD daemon in a Linux environment. It does not run a full board Junos. Which means that most of your commands and most of your configuration model works exactly as you expect it to, except for some important differences, which is effectively anything that doesn't directly interact with RPD. The biggest ones you'll notice is that a lot of diagnostic commands, ping, traceroute, ARP, don't run in the shell, don't run in the exec mode. You have to drop to the CRPD's bash shell to run those. So just be aware of that, and again, ask questions. We've got some experience with this, so feel free to reach out. A little bit about the NetBox instance. It runs on port 8000 plain text. again, we're all friends here. There's a default user password set. And once you're logged in, you can go into the admin account profile to generate an API token, which you can then utilize for API calls. There's a link to the NetBox-py library, which is the standard Python library for interacting with NetBox. Instead of making API calls, you are interacting with objects that abstract away the API behind the scenes. Pretty effective. There is a demo data set that has been pre-populated. So if you log in, you'll see a whole bunch of dummy sites and devices. There are some instructions for clearing all that out and starting with an empty data set if you prefer that. An idea I'll throw out there if anyone's interested, given that NetBox is running on the same host as the C Lab, it would be interesting to see if someone's interested. It would be interesting to see if anyone figures out techniques for populating NetBox data from the running state of the lab. Personally speaking, that's interesting to me. If it's interesting to anybody else, I'd like to hear from you. Jeremy did a quick screenshot to show what the NetBox UI looks like. So this is what you'll see in the lab instance. You'll see a whole bunch of Dunder Mifflin offices. And as you go into regions, site groups, you'll see other pre-populated data as well, which you can, if you're working with it, you can just create your own sites and devices alongside that, or clear it all out and start from scratch. Here is the page where you generate your API token. So once you have that token, you can use that in your scripts to access access objects and interact with NetBox programmatically. My experience with NetBox is via the REST API. I haven't tried to use GraphQL, so that's something that's also interested me as well. If other people want to play with that, I'd be happy to watch and learn myself. That's it for me. Thank you all for joining. Let's keep communicating and coordinating in the Slack channel. And for those of you who are going to be on site in Atlanta, I'm looking forward to seeing y'all on Saturday or Sunday. So, thank you all very much, and looking forward to see you hacking. Thanks.